rhombus, circumscribed, angles, this thing. It's geometry. With me, Miss Cohen.
Hi, we are doing lesson 2.3 today. So unit 2, lesson 3, and the sort of topic today is, are the lines parallel? So go ahead and pause if you need to get that down. And once you do, find a new page in your book. And here's today's, this is the date I'm doing it, but obviously you put your date, lesson 2.3, and then the essential question, how can you prove that two lines are parallel? So pause if you need to get that down. And then we're going to start by drawing a diagram and thinking about it a little. So I'm going to use my protractor to draw two parallel lines. I can just draw one line there and one line there. So with most protractors, you can draw two parallel lines really easily. And then I'm going to draw another line going through, and this, of course, is the transversal. And we're not going to mark that these lines are parallel because today's lesson is really about looking at a diagram and deciding, are the lines parallel? Last class, I told you they were parallel, and then we learned a whole bunch of relationships. But today, we're going to do kind of the opposite of that. So once you have your lines drawn, I want you to write in just a couple of things. We are going to write in that this here is 50 degrees, and this angle here is 120 degrees. Okay, and just from that information, we can determine whether or not these two lines are parallel. So I want you to think for a second, do you think they're parallel? Why or why not? And I'm going to take a different color, and we're going to fill in all the other angles that we know about here. So if this is 50 degrees, then this is a vertical angle to that, and it has to be 50 degrees as well. And then, of course, these two angles form a linear pair. They add up to 180, and so 180 minus 50 is 130. And I would like for you to take a moment on your own and figure out what's that angle, and then what are those three angles based on that angle measure. So go ahead and do that, and then check up here when you're done. Okay, so this is what I come up with. If this is 120 degrees, then these three have to be 60, 120, and 60. If this is 50 degrees, then these three have to be 130, 50, and 130. And so I hope you can see that these lines, even though I drew them to be parallel, they're not in fact parallel based on those angle measures. Because if they were, then this intersection would match this intersection, and it doesn't. And so what we're going to say off to the side is that the 50 degrees plus 120 degrees, these are same side interior angles, and we learned from our last lesson that same side interior should be supplementary. They should add up to 180, and in this case they don't. And so we're going to put a little slash through the equal sign, and then we're going to write below same side interior angles should be supplementary. And they're not. Therefore, these lines are not parallel. So we're going to write all that out. Therefore, the lines are not parallel. Okay? And that's really what today's lesson is all about. So we've got two same side interior angles. They should be supplementary. They're not. Therefore, these lines are not parallel. And if we want to get really technical, we would say these angles are not, or these lines are not parallel by the converse of the same side interior angles theorem. I'm less worried about that tricky vocab than I am about you being able to identify what's the angle relationship, should they be congruent or supplementary, are they, therefore are the lines parallel or not. This is still considered a transversal, and we still have two intersected lines, it's just that those lines aren't parallel. So we're going to go ahead and call that example 1. Simple enough. And let's look at example 2. I'd like you to draw 2 vertical lines this time. Maybe they're parallel, maybe they're not, we don't know. 2 vertical lines. And then draw a transversal going through them. So we're going to say here that this angle is 125 degrees. And this angle is 125 degrees. And so the question is that enough information to know whether the lines are parallel or not? And it turns out that we need to think, what is the relationship here? What's it called? And in this case, they're on the interior of the parallel lines, or of the lines, I should say, and they're on opposite sides of the transversal. One's above it and one's below. So think about what that relationship is. Look back at your notes if you need to. These are alternate because they're on alternate sides of the transversal. Interior because they're on the interior of the parallel lines. They're alternate interior angles. And then if the lines are parallel, then those angles are congruent. So they should be congruent. And in this case, they are, because 125 equals 125. And by the converse of the alternate interior angles theorem, that means that these 2 lines are parallel. So we're going to say, therefore, the lines are parallel. And that's it. A converse just means you flip around the if and then statement. So the alternate interior angles theorem said, if 2 lines are parallel, then the alternate angles are congruent. And we're flipping that around. Now we're saying if the alternate interior angles are congruent, then our lines are parallel. And so that's what a converse is. So here we're going to mark that those lines are parallel now that we know it. We're going to do just 2 more examples. Example 3. Two parallel lines looking a bit like that. Maybe they're parallel, maybe they're not. Transversal. This little angle here is x plus 5 degrees. This angle here is x plus 10 degrees. And the question is, are they parallel? Are the lines parallel? So again, we need to think, what is the relationship here between these 2 angles? And so here's our transversal. Those angles are on opposite sides of the transversal, so that means we're dealing with alternate something. And here are my lines that maybe are parallel, right? And those angles are on the interior of that. So again, these are alternate interior angles. I'm going to use my symbol there. So I'm dealing with alternate interior angles, and they should be congruent. And so the question is, are they congruent? And this is weird because we don't have angle measures, we have algebraic expressions. And so let's go ahead and see if they're equal to each other. So the question is, does x plus 5 equal x plus 10? And then just saying that should make you go, huh? Does x plus 5 equal x plus 10? This is a very weird thing to think about. Normally when we see an equation like this, we try to solve it. And so let's try to get all our variables to one side. If I bounce this 1x, then I would take away x from both sides. X minus x is 0, the 5 comes down. And then over here, x minus x is 0, and the 10 comes down. And there's no situation in the universe where 5 is equal to 10. This is just not true. no matter what value of x we put here and here, we're never going to get the same thing on both sides, right? If I put a 10 here, I would have 15 and 20. If I put a 20 here, I would have 25 and 30. There's no situation where these angles are going to be the same based on those expressions. And that means that no matter what, those angles are not congruent. So are the lines parallel? No. And we need to write the lines are not parallel. I want to do one more example here. Example 4. So draw something like that for me. Here's my transversal. Here are my two intersected lines, and I want to know if those lines are parallel. And so I'm going to give you a little bit of information. Okay. So my question this time is, and you need to write this down, if x equals 8, are the lines parallel? Oops, you can't see all of that. So I have this sort of, let me move this guy. Sorry to make you dizzy. Okay. So I have this kind of weird diagram with those two angles, and I have expressions again, but this is actually telling me, like, figure all this out when x is equal to 8. So first thing I want to do is identify what's the relationship here. This angle is the top left angle in this intersection, and this angle is also the top left angle in the intersection. So take a minute and see if you can remember what the name of that relationship is. Hopefully you remember that these are called corresponding angles. And corresponding angles should be, we need to decide, should they be supplementary or should they be congruent? And in this case, corresponding angles should be congruent. And so we're going to see if they are when x is 8. So I want to see if 19x minus 10, I want to know what that is when x is 8. And then I want to know what 15x plus 22 is when x is 8. So what we're going to do is replace the x with 8, 19 times 8 minus 10, and replace the x with 8 over here. And I have to walk to get my calculator. You guys figure that out while I'm taking my walk. Okay, so 19 times 8 minus 10 is 142. So when x is 8, this angle here is 142 degrees. And that only happens when x is 8. Over here, we have 15 times 8 plus 22, 142. So when x is 8, this angle is also 142 degrees. So when x is 8, those two angles are congruent, and corresponding angles should be congruent for lines to be parallel. So by the converse of the corresponding angles theorem, these two lines are parallel, and we can put our little flags on them. Okay, and we should write somewhere, they are parallel. And I would have to write my summary on the next page, but take a minute and write a summary. Really, the way we prove that two lines are parallel, that was our essential question, is by looking to see if the angle relationships are what we think they should be, right? Like, if they're supposed to be supplementary, are they? If they are, we're dealing with parallel lines. If they're not, we're dealing with non-parallel lines. If the angles are supposed to be congruent for parallel lines, and they are, then we know we're dealing with parallel lines, and if they're not, then we know we're not dealing with parallel lines. So pretty easy, short lesson. We're done for today. Go ahead and write your summary, and then you're done too.